Now I just want to look at equations where they're in the form where one fraction equals another fraction. So A on B equals C on D. So basically to get rid of those denominators, the quickest and easiest way to do that, see how that's divided by D? You can move it to that side and make it times. So then it ends up being like A times, and then you can go times the D. Okay, and then if you look at the B, so there's the B, and you move that to that side, and that's a division there, then that ends up being C, which is already there, times, and we're moving the B across, so it's times the B. Okay, and then that will be a much easier equation to solve than the one with the denominator that's there. So if we now apply this to something like this, 2x plus 1 on 3 equals x minus 4 on 5, for example. If I use the cross-multiplying method, so the 5 will go up there and become times, and the 3 will go up there and become times, because it's going from divided by 3 to times 3, divided by 5 to times 5, the opposite on the other side. So when we write the next line, it's 5 times. Now, if you just wrote 2x plus 1, it's because of order of operation, it's actually really only multiplying the 2x. So because there are two terms there, you need to put a bracket around the double term. And the same on the other side. When you multiply that, that's going to be 3. And you could put times x minus 4, but it's effectively only going to multiply the x and not the 4, so you need a set of brackets. So now all we're left to do here is we have to multiply and expand the brackets, and then we just have a normal equation with x on both sides. So 5 times 2 is 10x, and 5 times 1 is 5. 3 times x is 3x, and 3 times 4 is minus 12. So now you go ahead and we're going to solve this. We've got x on this side here. See that x there, 3x. So we don't want that. We want letters left, numbers right. Letters left, numbers right. So that's a plus 3x. So if we take the 3x away there, we take the 3x away there, because we've got to do the same thing on either sides of the equal sign. 10x minus 3x is 7x plus 5 equals the 3x go. Make sure that you actually collect the sign in front of the 12, that minus there. So make sure that you put minus 12. So if you go minus 5, the minus 5s will go out because I did the opposite sign. Remember, we're getting rid of the thing furthest away from the x first, not the one that's attached to it, because when you're working backwards, you're like peeling away from the outside until you can get to your prize, which is this x here. Okay, so looking at that now, we got 7x equals minus 12 minus 5 is minus 17. And the opposite to timesing by minus 7 is divide by minus 7. Minus 7. But once again, we know that division is much easily written with a fraction. And they'll cross out, because then you just get minus divided by minus is a plus. So the minuses will cancel out and you get 17 on 7. Okay, so I'm just going to look at one more example like this. But I'm going to show you that if I put the x's on the bottom, you can still use the same system. Okay, so if you're looking at this question here, we're going to do the same thing. We need a bracket around that one, and we need a bracket around that one. So this one's going to come up here and become times, because the opposite to division is times, and that one's going to come up there and become times. See, this is division, so this is divided by this thing in the bracket. When it moves there, it times. So this is divided by the thing in the bracket. When it moves to the other side, it will times. So it's 3 times x minus 4 equals 4 times 2x plus 1. So now expanding the brackets here, and expanding the other bracket. Multiply both things that are inside by what's outside. 3 times x is 3x, minus 3 times 4 is 12. 4 times 2 is 8x, plus 4 times 1 is 4. Okay, so we're now left with the situation again where we have x's on both sides. So letters to the left, numbers to the right. So we want to get rid of that 8 first. So because it is a plus, we're going to minus 8x, and we're going to do it to both sides. And we do it straight underneath the 3x, not with the 12, because you take 8x away from 3x. The 8x's go out. 3 minus 8 is minus 5x. Minus 12 equals, and what are we left here? We have plus 4. Okay, so remember we're trying to get to our prize. Our prize is the x here. We get rid of the thing furthest away from the x first, which is the minus 12. So we go plus 12 plus 12. So then we end up with minus 5x. The 12s will go out because that was the intention. We did the opposite sign, so they cancel. Plus 4 plus 12 is 16. And then we are going to divide by the minus 5. But we're going to remember that instead of division, we can just use our fraction bar because that means the same thing. And then we can just cancel out the minus 5. So we are just left with x equals 16 on minus 5. So just to make this clear too, 16 on minus 5 is the same as minus 16 on 5 or minus 16 on 5. Because that's a plus and a plus divided by a minus is a minus. A minus divided by a plus is a minus. Now, we tend to write the minuses either on top of the fraction or just out the front of the fraction, but we never write that on the denominator because it's much harder to find a common denominator when you have something that is negative. So we change it to the positive, or just simply, when you get a situation like that, move the minus to the top to get minus 16 on 5.